To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Welcome to today's lesson, students. So, in the previous chapter, we looked at one application of electrolysis. We discussed the downcell method that is used to industrially manufacture or extract sodium metal. So, you can remember the process and the cell that was used in the industry. Now, we move on to another application, that is electroplating. Now, you are familiar with this also. Now, we started this lesson by looking at how gold is plated on other jewelries. Jewelry is made up of either steel or other metals which is plated with gold. There are gold jewelry made with only gold metal, but at the same time you can gold plate jewelry also. Not only jewelry, even statues and other objects. Not only gold. There are other metals being plated onto even steel. Now we discuss chromium, nickel, they can be plated onto steel. Copper can be plated into an iron object, on the surface of an iron object. So like that, different metals are coated on other metal objects. So that is what we discuss under electroplating. At the beginning of this lesson, it was stated that electroplating is used to coat jewelry with gold, coating gold on to other jewelry. In addition to that, think about the ornamental objects used to decorate houses. Now that is what I said, copper. You have seen copper vases. Some are made up of brass. Some are made with steel and copper plated. There are various ornaments. So there we plate it onto that particular ornament. Copper is plated onto that particular object. In many items such as vases, now these are some examples, vases, trays and door locks that shine with golden or silvery color. The metallic luster is given by a metal coating deposited on them. Even though they are made up of iron or steel, they don't have that luster and shine and that silvery or golden color. But that is obtained by coating that another metal onto this object, like vases, trays and door locks. So that is what you need to remember. So if we look at what electroplating is, applying a thin metallic layer on a given surface using electrolysis is referred to as electroplating. So let's say if you have a small object, say a metal plate made up of iron, let's say, or steel. This is a steel plate. On the surface of the steel plate, if you have a very thin film of, let's say, nickel, a thin film of nickel, then that is known as electroplating. Now here you can't just paint it with nickel. You can't do that. You have to coat it onto it and the nickel has to be attached to the surface of steel. It should deposit on it. So that is why we need to carry out an electrolysis process. So coating, applying a thin metallic layer on a given surface using electrolysis is referred to as electroplating. So that is the introduction. Now let's look at electrolysis, electroplating in more detail. So then we will discuss electroplating. Generally, the coating is a less reactive method. So you have to remember that, students, it is a less reactive method. So why do we need to select a less reactive metal? One thing, if you coat a highly reactive metal, there's no purpose because that itself will react with air or water. So there will be no proper coating available. So if it is a less reactive metal, it will be more inert, chemically inert. So it will remain on the surface of the object and it will give the desired properties. So as examples, we can consider the metals tin, copper, silver and chromium. In addition to this, you all know even gold is coated onto certain object. Gold plating, even in the previous slide we discussed gold plating, and also nickel plating. So those are also metals that can be coated. Nickel and gold. So usually tin, copper, silver, chromium, even nickel and gold. Now you can remember, if you recall the activity series, silver, platinum, gold. They are the least reactive metals. And even tin, chromium, copper, those are also less reactive. So when they are less reactive, they are chemically inert, the coating will last for a longer time. So then this metal that is coated onto another object will have certain special properties that are absent in the object. Now for example, if we have an object made up of iron. Now iron usually rusts. You all know iron is a very useful metal. We use iron to make many objects as well as many structures. But iron undergoes rusting. Now that can become a disadvantage. To increase the long-lastingness of that particular iron object, we coat it with another metal. Maybe depending on the requirement, it can be copper, it can be silver, chromium or nickel plating. Then it can be used for a longer time. So there, iron undergoes rusting, which is not a good property, but the metal that is coated, for example nickel or chromium or silver, does not rust. So that is a property of the metal that is being coated, a special property. That is how we select metals for coating. The metal that is plated needs to have a certain special property which is absent for the surface that it is plated. So the surface that is plated is iron. That cannot withstand rusting, or it doesn't have the resistance to rusting. But these metals will have the resistance to rusting. So that is a special property. Now if we write the special properties, one is resistance to rusting. Resistance to rusting. So that is a property that is absent in that object, but the metal has that property. Then it can have an attractive color. Now we said in the previous slide, vases, doorknobs and other metal ornaments. Now they need to have a nice color. Now anything made up of, let's say, iron or steel is not that attractive compared to the nickel coated, chromium coated or gold plated ornaments and objects, even copper plated ones. They are more attractive in their color. So that is another property, attractive color. So resistant to rusting, attractive color. In addition to that, the metal will have chemical inertness. Now again we said less reactive metal. Less reactive means they are chemically inert. They don't react that much. So that is another property of the metal that is plated. Chemical inertness. Chemical inertness. And also it should have a lustrous nature. What is lustrous nature? Luster is the shine of the metal. Now there are some metals that tarnish very quickly, but there are some metals that do not tarnish quickly. because normally metals can react with air, that is oxygen in air. Because of that, oxide layer forms and that reduces the shine. That is what we call as tarnishing. But there are metals that are chemically inert, so they don't react with oxygen in air. Because of that, they do have the lustrous nature throughout. So these are all properties usually related to one another. When we have a less reactive metal, so initially itself we said it should be a less reactive metal. The less reactive metal usually has these properties: resistance to rusting, attractive color, chemical inertness and lustrous nature. Attractive color of course depends on the metal, but these resistant to rusting, chemical inertness, and because of that the luster remains. Now even sodium has the luster only when you cut it freshly. But with time, very quickly the luster is lost. Even magnesium has a luster, but the luster is lost. It tarnishes with time because it reacts with oxygen and nitrogen in air. So you all know that. So these are properties of metals that are plated onto the other object. So you all know this. We will move on to the next slide where we continuously discuss electroplating of metals. So when electroplating objects, it is important to know the following. What are the important things? Now let us recall the electrolysis of copper sulfate so that you will understand these points more clearly. Now we have the electrolytic cell. We have copper sulfate, the two electrodes and the battery, the dry cell. So there. Positive, negative, did become positive, negative, and this is copper sulfate aqueous. Now, if you remember, there are the ions, there is Cu2 plus ion, H plus ion, OH minus ion, and sulfate ion. Now, out of these, Cu2 plus and H plus migrate towards the negative electrode. OH minus and SO2 minus migrate towards the positive electrode. And out of these, you all can remember students, copper ions get reduced. Why? In the activity series, they have less reactivity, or they are below in the activity series compared to H plus. So, this undergoes reduction. And also OH minus undergoes oxidation. We said when there are more than one negative ions, which undergoes oxidation depends on many factors. So we did not go into detail about the factors, but you all know when there is OH minus and sulfate, OH minus undergoes oxidation. Now out of these, this is the important one. Where does this deposit? It comes towards the negative electrode, and near the negative electrode, Cu2 plus aqueous takes up electrons and becomes Cu solid. So copper deposits at the cathode, that is the negative electrode. And this is copper sulfate. So what you need to remember is copper deposits as the cathode, that is the negative cathode. So this is the negative cathode. So if you want to copper plate an object, where do you need to have the object? It has to be the negative electrode. Then the copper ions from the solution deposit on that object. Now if you have this solution, with time what will happen? Copper ions are going to be used up. Then the solution can run out of copper ions. Then of course the copper plating will not be efficient. To avoid that, what we can do is we can use copper metal here. We can use a copper electrode. Now this is also something we discussed when we discussed the electrolytic cell. If you have a metal electrode as the anode, a metal electrode connected to the positive terminal, instead of OH minus ion undergoing oxidation, the metal will undergo oxidation. So here what will happen is instead of OH minus, that will not undergo oxidation, the copper ion will undergo oxidation. Solid becomes Cu2 plus aqueous, losing 2 electrons. So what we do is we use the metal that is going to be coated onto the object as the anode. So it will undergo oxidation. Copper ions will be given to the solution. At the same time, from the solution, copper ions will deposit on the cathode, that is the object. So continuously there will be a supply of copper ions. So those are the things you need to remember. The object has to be connected to the cathode, so the metal will deposit on it. And the anode has to be the metal that is going to be coated. And also the electrolyte solution should be an ionic solution of that particular metal, the salt solution of that metal that is coated onto the object. So those are the things that you need to remember when we do electroplating of an object. So I will write them down. Now here students, I have drawn this using the copper sulfate example because we have already discussed this. So you know what is happening. So with that, I am sure you all would have understood the important points. So here, object should be the negative anode. The cathode should be the metal to be coated. Then the electrolyte should be an aqueous solution of the metal salt. So we need to have the object at the negative anode. The cathode should be the metal that needs to be coated onto the object, and also the electrolyte should be an aqueous solution of the metal salt. And for a good quality electroplating, we need to use a dilute solution of this metal salt and also low amount of current. Less current should be passed for a longer period of time so that we get a very good quality plating. And the electroplating should be done slowly. So we have to write that as well. Concentration of the electrolyte should be low and a small current is supplied so that electroplating occurs slowly over a long period of time. This gives good quality plating. So here students, I use these examples so that you can easily understand the important factors to consider when electroplating an object. So if you are asked to write them, these are what you need to know. Object has to be the anode, the metal that is coated has to be the cathode, and the electrolyte should be the salt solution of that particular metal. And also the concentration of that electrolyte solution should be low, and electricity, the current supplied is also less, so that you can carry out the electrolytic process very slowly. It is done for a longer period of time so that you can get a very good quality plating. Those are the things you need to remember, students. So with that, I'll move on to the next slide. Suppose you need to coat an iron spoon with copper. What do you use as the anode and cathode of the electrolytic cell which you construct for this purpose? So there, I have already explained it using the previous cell. When I explained it to you all, now you know the iron spoon should be the cathode. That is the negative cathode. So there you can see iron spoon, cathode. That is the negative terminal. And if you are going to copper plate, copper rod or plate should be the anode. That is the positive terminal. So what do you use as the anode and cathode of the electrolytic cell which you construct for this? And what is the electrolyte you employ? What is the electrolyte? Electrolyte dilute copper sulfate solution. Solution. So it is the salt of that metal. You all have to remember this. And if you can recall, students, we have discussed in one of your previous grades, to gold plate something, gold plate another object, we use gold cyanide. If you want to silver plate an object, you use silver nitrate. So those are the solutions that are used to plate that particular metal, the respective metal. So if you want to copper plate an object, you need to use copper sulfate solution. With that, I'll move on to the next slide. So here we have an activity, copper plating an iron spoon. And we need these materials for the activity. We need an iron spoon, then copper, metal. It can be a rod or a sheet or a raw copper plate. It can be one of the three. Then we need connecting wires. We need a 9-volt battery. And also we need copper sulfate solution. Now you can remember copper sulfate is a blue color solution. So what do? You need to connect the iron spoon to what terminal? it should be connected to the negative terminal. And the copper plate should be connected to the positive terminal using the connecting wires. Then you dip both into a dilute solution of copper sulfate. And you have to observe what happens there. So I'll move on to the next slide where I discuss the procedure. So the method, this is what we do. Here you can see this is going to be the copper metal. And here we have the iron spoon. And this is copper sulfate solution. Copper sulfate solution. And here you can see, since that is the positive electrode, this becomes positive. So copper metal is the positive electrode. Here we have connected the spoon to the negative electrode. So the iron spoon will be the cathode and the copper metal will be the anode. This is going to be the anode and this is going to be the cathode. The cathode. So this is the method. That is the electrolytic cell used to copper plate an iron spoon. Connect the iron spoon and the copper plate to the cell by connecting wires and immerse them at once in the copper sulfate solution. That is the first step, and then you need to record the observation. So that is the method that is used to copper plate an iron spoon. A very simple procedure. Now let us go to the lab and do this activity. Okay students. So now we will do this activity to observe how electroplating takes place. To do that, now here I am going to plate copper onto the metal spoon. So for that we need an electrolyte solution that has the metal that has to be plated. So here we have copper sulfate. You all know the color of copper sulfate, blue color solution. Then I have an iron spoon, normal stainless steel spoon. So onto that we will be plating copper. So we have the anode where oxidation takes place, and here it is going to be the positive electrode, and the cathode where the reduction takes place is going to be the negative electrode. So when we need to electroplate an object, we need to have the object connected to the cathode. So there it has to be connected to the negative electrode. The spoon has to be connected to the negative electrode. So here I have the dry cells. Now you all know the positive and negative terminals. The black color wire is connected to the negative terminal. Red color wire is connected to the positive terminal. So here I will have to connect the object to the negative terminal. So that is going to be the black color wire, and the positive terminal is going to be the copper metal. So the object that has to be plated is connected to the negative terminal, and the metal that has to be plated should be the anode. So here we have a copper plate that is connected to the positive terminal. Now if we dip these two into the solution, that is the electrolyte solution, you will see the change. Here I am going to dip both the electrodes there, object and the copper electrode. You all have to observe what happens. You have to observe the spoon and the copper plate. So here students, you all can see, if you look at the spoon closely, can you see at the edges of the spoon, the outer line of the spoon, you can see a reddish brown color deposit, a brownish color deposit. So you know copper metal is brownish in color. So that dissolves, goes into the solution, and the copper ions from the solution deposit on the metal spoon. You can see the deposit starting to take place on the spoon. Can you all see that clearly students? The brown color deposit on the spoon. So here you can see, students, now on the spoon you can see the brownish color deposit. So copper, now you can compare. The copper plate dissolves, it goes into the solution, and the copper ions from the solution deposit on the spoon. Has the color changed in any way? Color of copper sulfate solution. Is it the same or different? You can see it's the same color. So because we have copper as the anode, copper ions from anode dissolve and go into the solution. From the solution, copper deposits on the spoon. But the amount of copper sulfate in the solution does not change. So therefore, the color does not change. So if we keep it for a longer time, you will see more copper depositing on the spoon. But here, of course, we have seen the copper deposit. Here you can see the copper deposited around the spoon more clearly. So this is a normal laboratory technique where we try to understand the copper plating or metal plating, or what we call as the electroplating of copper onto the object. You have to connect the object to the cathode. So there copper ions will take up electrons from the cathode, which is the negative electrode, and it will deposit on the object. At the same time, you connect the metal that has to be deposited as the anode. So here this is the positive electrode. So here what will happen is there will be oxidation taking place, that is copper metal will dissolve and become copper ions. It will go into the solution. So because of that, the amount of copper ions, that is copper sulfate in the solution, does not change. So the color of solution does not change. You see the deposit at the cathode, dissolving of the anode, but no change in the electrolyte solution. The color of copper sulfate does not change. So those are the observations that you will get during electroplating of copper to a metal object using copper sulfate solution. Okay, students. So did you all observe the activity clearly? I'm sure you all did. So what did you see? You saw the copper deposited on the iron spoon. I showed you all that. And also, while the process was happening, you were able to see the copper plate, that is the anode, dissolving. Was there any color change in the copper sulfate solution? No, there was no color change. So the copper sulfate solution remained blue in color. At the same time, the copper metal, the copper rod or the copper plate dissolves, and also copper is deposited on the iron spoon. Those are the observations. So if we write the observations, blue color of the solution does not change. Copper metal, that is the anode, dissolves. Then reddish brown copper deposits on the, we can say, iron spoon. So those are the observations we got. Blue color of the solution does not change. Copper metal, that is the anode, dissolves, and the reddish brown copper deposits on the iron spoon. So those were the observations. So what are the reactions? You all are familiar with the reactions. Now you are familiar with the electrolytic cell also. You can remember anode is what? Anode is copper. So there it should be oxidation, the copper solid, loses electrons and becomes Cu2 plus aqueous. So that is why the anode, the copper dissolves. Copper dissolves. Now this is not the observation, students. This is the explanation related to the observations. And near the cathode, where you have the metal spoon, what happens there? Copper ions from the solution take up electrons and deposit as copper solid. So copper anode dissolves, at the same time copper deposits at the cathode. So copper is given to the solution, copper is taken from the solution. That is why the color of copper sulfate does not change. While copper is being deposited on the spoon, anode dissolves and supplies copper ions to the solution. So the amount or the concentration of copper in the solution does not change. Therefore, the blue color of the solution does not change. So this is the anodic half reaction, that is the oxidation, and that is the cathodic half reaction, that is the reduction. You all need to know these reactions as well. So I'll write it again in the next slide also. So there are different ions present in the solution that I explained to you all before in one of the slides. You can remember there is copper ions, that is Cu2 plus aqueous from copper sulfate. Then there is sulfate ions. What is that? SO4 2 minus aqueous. Again from copper sulfate. So these two we get from copper sulfate aqueous. Then there is H plus ions and OH minus ions. These are from water, H2O. Now water, you all know, is a covalent compound, but even at 25 degrees Celsius, we have discussed this before, it can dissociate to a very small amount. A small amount of water dissociates. But in the presence of ionic compounds, a little more water dissociates and forms H plus and OH minus ions. So there are 4 ions. Out of those, copper ions get deposited at the cathode, and also since we use a copper rod as the anode, that undergoes oxidation. So this is what you need to remember. So then if we look at the anodic reaction. So anodic or positive electrode reaction, and you all know there are 2 ions, sulfate and OH minus ions in the solution migrate towards the anode. And of them, OH minus ions preferentially tend to undergo oxidation. That is the first method that we discuss. Now when I explain the factors or consider what you need to remember related to electrolysis or electroplating, I explain where OH minus ions go towards the anode and they get oxidized. So what we expect to happen is this. Therefore, it can be anticipated that the reaction 4OH minus aqueous becoming 2H2O liquid plus O2 gas plus 4 electrons, that is losing electrons, occurs at the anode. That is the oxidation that we expect to happen. But as I explained to you all before, you all know this does not happen. Why? Because we use copper as the anode. So, however, it does not occur at the anode. This is important. However, it does not occur at the anode. So, you have to understand this part. The whole thing, it's important. As the anode is a metal, oxidation of metal atoms into metal ions is more feasible. Hence, the anodic reaction is what? Copper solid becoming copper 2 plus aqueous by losing 2 electrons. That is the anodic reaction. So, therefore, that means the anode dissolves gradually. That is what you saw. The anode dissolves gradually. So, what happens at the cathode? We will write that in the next slide. Cathodic or negative electrode reaction. So, what happens here? The solution contains copper ions and a little amount of H plus ions produced by the dissociation of water. So, what are the ions? Copper ions and a little amount of H plus ions produced by the dissociation of water. Of these, copper ion, which is less reactivity, shows a greater tendency to be reduced. Copper ions are lower in the activity series, so it has less reactivity. Normally, the ion that has less reactivity undergoes reduction. Therefore, the cathodic reaction is the following. So, what is the cathodic reaction? Copper 2 plus aqueous takes up electrons and deposit as copper solid. As a result, the cathode, that is the iron spoon, gets coated with copper. So, that is what happens there. The iron spoon gets coated with copper. So, from the two reactions, you all can understand. If we go back to the previous slide, here you saw copper dissolves gradually, and here at the cathode, copper deposits. Like I told you all, copper is depositing, at the same time copper is dissolving, and copper ions are entering the electrolyte solution. That is why the color of copper sulfate does not change. So, these are the reactions taking place when an iron spoon is coated with copper. So, similar to that, there are other metals coated onto different metal objects. So, that is depending on the requirement. But what you need to remember is, always you need to use the salt solution of the metal to be coated as the electrolyte. It has to be a dilute solution, and the electrolysis should be done slowly so that the electroplating is of high quality. At the same time, the anode should be the metal that should be coated onto the object, and the object should be the cathode. So, those are the things that you need to remember, students. So, with that, I will end this chapter, and in the next chapter, we will be moving on to a new topic, that is corrosion of metals and rusting of iron.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.